LeetCode Problem 875, Koko eating bananas. So this problem gives us Koko, right? And there are basically an array of bundled bananas. And then our job is to find out how many bananas Koko can eat per hour at the eating speed of k, because there's a guard, right? And then you come back in h hours. So basically, how fast Koko can eat before the guard comes back within h hours. Uh, and yeah, so okay, so for example, this we have this pile here, and the output 4 is because the h is 8, right? So Koko eats 4 here, and then if there is no remaining bananas, Koko will not do anything. You will just instantly eat all of them. But this will take 1 hour. This will take 2 hours, right? Because 6 minus 4 is 2, and then the remaining 2, Koko will have to spend another hour to eat. So in total, this is already 3, and this is another 2. So total is already 2 plus 2 is, right? 2 plus 2 is 4, 5, right? And then this you have 3. 5 plus 3 is 8, right? So within 8 hours, Koko would need an eating speed of 4 to finish all of the pile, right? And the reason why Koko cannot just eat 11 bananas at once is because Koko likes to eat slowly, but still wants to finish eating all of the bananas before the guards return. Okay, that's enough about Koko. And the solution I have to this problem is to use a binary search, where the left pointer is the minimum amount of bananas Koko can eat per hour, and the right pointer is the maximum amount of bananas that Koko can eat per hour, right? And then after that, we iterate through every pile and check the total, whether or not the total is lesser or equal than the hours from the guards. And depending on that, we will adjust the left or right pointer accordingly lah, right? Okay, so what I mean by that is, okay, let me result or just rename some of the variables here so it's easy to see. Left, right, this is mid, right? Okay, so right now our left is 1, right? Because the minimum amount of bananas Koko can eat is 1. And our right is, okay, let's say we are using this example. Example is this, right? With h equals to 8. Okay, so our right in this case will be 11, because 11 is the highest, is the most banana in the pile. Okay, let's have a total, and then the middle pointer, right? Okay, so while the left is less than equal, right? Okay, so this basically is needed for every binary search. But after that, we find out the mid, right? So the mid is basically left plus right divided by 2. So in this case, the mid is 6, right? So because 12 divided by 2 is 6. And then for every pile in the array given, we have to calculate what's the total amount of hour Koko will use if the eating speed is 6, right? For this case, it will be 1, 1, 2, 2, which means it will be 6, total will be 6. And since the total is less than equals to h, right? That means Koko can spend lesser time, or like, yeah, Koko can spend more time eating on the banana. So we have to reduce the amount of bananas Koko will eat per hour lah. And the way we do it is that we move the right pointer to the left side, right? So imagine if the binary search we're searching right now is like this, and then you have 11 here. So we have to move the middle pointer, and we have to move the right pointer, which is pointing to at 11 right now, to the left side of the array. Right. Okay. This is to still keep track of the result, right? So we don't lose what we have to output. So result is 6. Okay. Let me do this instead. Okay. So let's say now our right has become in the middle, which is 6, but we have to minus 1. So our right now is 5, right? Our right now is 5. And then we find the middle again, which in this case will be 3. Okay, after that, we calculate the total again, the total amount of time Koko will need to use to eat all of the bananas here using eating speed of 3 bananas per hour. And if you do that, then it will be, this will be 1, 2, right? I'll just write this up. 1, 2, this will be 3, this will be 4, right? So the total will be 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10. Right, total will be 10. And since now that the total exceeds the 8 hours, it means Koko cannot finish all the bananas. So we have to move the left pointer to the right side now. Right. So let's say just now it was like 6, right? Right. And then we move to 3, right? This. So now we have to find out the number in between 3 and 6, right? So we move the left pointer to 3, or in this case to 4 lah, right? Yeah, to 4. This is 5. Okay. So after that, let's move the left pointer to 4. And if we were to combine them, so it will be 9. 9 divided by 2 will be 4. Okay. And then we calculate again all the total. So in this case, the total will be 1, 2, 2, 3. And then this total will be 1 plus 2 is 3. 3 plus 2 is 5. 5 plus 3 is 8. So in this case, our total is equals to H. Our total is 8, right? And then we calculate the results again. And since right now our results is our results now turns to 4, right? Over here, yeah. So it's 4. Okay. And then after that, we move the right pointer again to mid minus 1, which is 4 again. So it'll be 4 here. But since now that both left and right pointers are the same, that means the binary search ended, and so we can just exit the iteration and just return the result. Yeah, so that's how my algorithm works. That's all I have to show. Thanks.